Hello, and thank you for joining me today as we begin our discussion on atomic structure. So this is the start of a new unit. We're going to talk about the atom. And so in this particular video, we're going to look at naming elements and identifying names and symbols of common ones, which we've done a little bit of already. So we're going to expand that. We're going to describe the electron cloud model of the atom. And then we will talk about quarks and other subatomic particles, along with how electrons are arranged in an atom as well. So we're going to get through all of this today. Let's get started. So first off, atomic components. Atoms are the smallest pieces of matter that still retain the properties of the element. For example, there's a copper wire, a bar of silver, a gold coin, a neon gas in a tube. All of those are atoms that we use in everyday life. Smallest piece of matter, they can't get any simpler. But atoms do have smaller components. And so what makes up an atom? So there are three things inside of an atom. One of them is a proton, one of them is a neutron, and one of them is an electron. So protons are particles with a charge of positive 1. Neutrons are neutral particles that don't have a charge, and electrons are a particle with a charge of negative 1. If you look up here, you'll notice that all the positives are in the center here, along with the ones that don't have a charge. So your protons and neutrons are all found in the middle. This is called the nucleus. So these guys are found in the nucleus, and these guys are found in the nucleus. Electrons are going around the outside. We call this the electron cloud, which we're going to talk more about in the next video. The electron cloud goes around the outside. And so we have protons and neutrons, and we just kind of talked about, we find these guys in the nucleus, which is a small, positively charged center of an atom. So this is what a nucleus is. It's found in the center. It's very small, very dense, and has a positive charge. And the reason it's got a positive charge is because it has these protons. So positive charges and no charges leave a positive charge overall. We also have these electrons. So electrons are found in the outside of the nucleus in what we know as what we call the electron cloud. This is just a region of space where electrons are likely to be found. So it's very hard to tell exactly where an electron is, but we know that within this region somewhere are going to be the electrons, and they are very tiny. So in your notes, something that's really nice to have is just a comparison. So here's a chart that if you make a 4x4 chart with particle, location, mass, and charge at the top, you can then copy this down. This will help you out with, hey, protons are found in the nucleus. They have a mass of 1. AMU stands for atomic mass unit. So protons have a mass of 1 atomic mass unit, neutrons have a mass of 1 atomic mass unit, and electrons have a mass of 0 atomic mass units. And it's not actually 0, but it's like 1/1000th of a proton and a neutron, so it doesn't change anything. An electron is not going to change the overall mass of the atom by a noticeable or marginal amount. So we call them AMUs, atomic mass units. So 1, 1, and 0 charges. Protons are positive, neutrons are neutral, electrons are negative. So just a nice little comparison chart that you can have and utilize and help you become familiar with parts of an atom. Other subatomic particles. So the question is, are there particles that are smaller than protons, neutrons, and electrons, or is this as small as it gets? And what they've discovered through different tests is that protons and neutrons are actually made of smaller pieces. And we call these smaller pieces quarks. We're going to talk about this on the next slide. But you'll notice that protons have 2 up quarks and 1 down quark, and neutrons have 2 down quarks and 1 up quark. And these have partial charges. So the up quark has 2/3 of a positive charge. So if I have 2 of those, I have 4/3. The down quark has a negative 1/3 of a charge. So 2/3 plus 2/3 is 4/3, minus 1/3 is 3/3, which is 1. And on the neutron side, we have 1 positive, or 1 up and 2 down. So 2/3, that's not right. We should have 2/3 minus 1/3 minus 1/3 equals 0. And that's where neutrons don't have a charge. But you just need to know that quarks are found inside of protons and neutrons. They are tiny particles. This is, and there are 6 types of quarks. You don't need to know individuals, but it's just to know there are 6 types of these quarks. This big thing in red is known as a particle accelerator. And so this is massive, by the way. This is like over a mile wide, a mile in diameter. But what they do is they take particles and they start them up here and they run them through a figure 8, kind of like derby cars, that they run their particles through these accelerators. And then the goal is to have them collide here. If they can get a collision here, there's all sorts of detectors to determine what is coming out of these collisions. And this is where we've discovered quarks. In that there was a collision and there's these particles that weren't there before. That's how quarks have been discovered. So this is what's happening. They're ran through and they collide here in the middle, and that's where you get your detection pieces. All right. Some review questions quick, and then I'm going to make another video for the history of an atom. So what 3 things make up an atom? And then what are protons and neutrons made of? Thank you very much for your time and attention today. I look forward to talking about the rest of our unit on atoms and atomic theory with you, and I will see you next time.